Hello and welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronic supply chain fields. I'm Mike Buetow, Editor-in-Chief of PCD&F and Circuits Assembly. First, a word from today's sponsor. This podcast is sponsored by Printed Circuit University. Printed Circuit University offers flexible, affordable electronics education on demand. Visit printedcircuituniversity.com to see more than 100 hours of online classes from some of the top professionals in their fields. My guests today are Larry Marcanti, Executive Director of the High Density Packaging User Group, also known as HDP, and his colleague Madan Jagernauth, who is Marketing Director and Project Facilitator. Thank you both for joining us on PCB Chat. It's always good to catch up with what's going on at HDP. As background, HDP is a consortium of more than 50 global companies that conceives and runs projects on electronics packaging and reliability. It has completed more than 50 such projects over the course of its 25 years. This is a classic example of how companies in an industry, sometimes even competitors, can collaborate on a much-needed research in a cost-effective manner. Larry, I know HDP just held its semi-annual meeting in October. Can you tell us a little bit about how that went? Were you able to actually get back together in person for a change?
Hi, Mike. Yeah, unfortunately, we weren't able to get back and do an in-person meeting. But over the COVID times, we've had a lot of practice with our virtual meetings. And we're also set up to run most of our projects virtually as well. We've got a pretty good infrastructure for running meetings in that manner. I guess the real issue that you run into with having a virtual meeting is the collaboration, sort of get together of several people at the end of the day. Also, the interaction makes it a little bit more difficult, but we've been able to get around that. We hope to have our February meeting in California this coming year, and that will be our first face-to-face meeting in the last, it's been almost 18 months now. So we're working towards that goal.
Do you have dates set for that February meeting?
It's going to be one of the last 2 weeks in February. We're working on with our sponsor company. Each one of our companies sponsors our face-to-face meeting, and we're working with them in trying to establish the date right now.
I'm looking at a list of projects that HDP has going on right now, and it's pretty thorough. I see 24 in total, including 3 in the definition stage. For our audience, could you explain what that means?
Sure. The definition stage is how we prepare for running a successful project. What we do during that stage is we establish what a design of experiments would be for the particular project. We look at the resources required to run the project. We have all those things lined up, and it takes a lot of work in the definition phase for our project facilitators to coordinate with all our member companies to make sure we're focusing in on a concise set of deliverables that we can achieve over an 18-month period. So that's the main activity during that cycle. After the definition phase, we go to our board of directors, and the facilitator will present all the details around the project, the deliverables, the resources, and a little bit of background on the project. And based on them following our thrust in HDP to look at new electronics areas, board of directors either approves or disapproves the project to go into the implementation phase. Once things are in implementation, then it's pretty much run by the schedule.
And the facilitator is a HDP employee, correct?
Yes, that's an HDP staff member. We have about 7 facilitators that work on different projects. We have a couple in Asia. We have one in Canada, and about 4 in the U.S.
But the team leader is somebody that's coming from one of your member companies.
Yeah, the team leader is always always from a member company. They provide the technical direction for the projects. Facilitators have a lot of technical background, but their main responsibility is to make sure the project's on schedule, that we have it resourced properly, and that we're working towards a schedule. And he's responsible for meeting minutes, setting up calls. We typically try to have a cadence of about every 2 weeks. We'll have a project call on each project. So that's some of the background that's always going on as far as working these projects.
I know not every project will actually be followed through to completion for one reason or another, but I'm guessing that every project actually does have a timeline.
Yes, they do. We have a schedule that's set when it goes into the implementation phase, and we work to adhere to that schedule. At our member meetings, we review how the project's doing to schedule. Sometimes there's unforeseen problems, like your lab is closed because of COVID, and you can't get in to work on the test parts. But that's been an issue that we've had here recently. But we pretty much try and adhere to the schedules that are set at going into implementation.
Is there any limit to the number of members that can participate in the project?
No, all our members can participate in as many projects as they want. The projects are open to participation outside of HDP in the idea and definition phase. Once we go into implementation, only members can participate. So that's kind of what our bylaws work.
And that member list, we don't need to get into real detail yet, but that includes a lot of blue chip companies and really kind of cuts across the whole electronic supply chain.
Yes, it does. We have members from materials standpoint all the way to the assembly houses, contract manufacturers, and OEMs. So I think it's important to have all three of those types of companies involved, because they all bring something to the table as far as investigating a new process or a technology.
If a member company brings an issue to HDP and it's something that they want the consortium to explore, does it have to get seconded or third? Or, I mean, does it, what level of support is required for you to proceed?
Well, we need to at least have two of our members that are interested in the project. That's basically all it takes, and then it has to go through. Since we do most of our work is in kind, we also may have to convince maybe a PCB supplier that it's in his best interest to provide test boards for it. So that's some of the ins and outs that we have. We try and focus on printed circuit board technology type projects, and that's sort of our bread and butter. And we just recently also presented at the member meeting an annual report. Every year we go through and we put together a synopsis of all our projects, and that synopsis we use as a recruiting tool and also to inform our members. And that was just completed for our last year period. So that was an important part of our member meeting that we had in October.
Do you make that synopsis available on your website or your LinkedIn page?
It is available on our website. I'm not sure if it's available on our LinkedIn page or not.
Now, what did some of the recently finished projects look at, and what can you tell us about the results? And I say that knowing that because of HDP membership rules, there are strict limitations as to what can be shared outside of the consortium.
Well, we're just wrapping up a project on back drill under BGAs. So we're going to be presenting a paper on that at Apex coming up. So it's a very good project, and it's one of the critical items that our members sort of brought together. If you take a look at large BGA sites, that we use microvias in order to help with the channel routing for all the ins and outs in and out of a large BGA. Well, there's a lot of issues when you do back drill that you have to have very controlled dielectric thicknesses so that you're drilling down to the proper layer. There's also an issue with copper smear that can cause electromigration type problems between layers. And this study looked at a whole variety of different processes, three different processes for fabricating the microvias, and it also looked at biased highly accelerated uh, temperature cycling testing to look at the reliability of the parts. And that paper will be presented at Apex, as I mentioned. Some very interesting results came out of that. There's test data. There's uh, quite a bit of information that we're sharing on that. We designed a specific coupon to take a look at different PCB design rules in that project to look at copper pad sizes, what is the tolerance as far as drilling goes, and we designed a test coupon that looks at those types of capabilities for a manufacturer. So that all will be covered in the paper that has been submitted and accepted for Apex coming up.
For companies who are members, what do they get access to that wouldn't necessarily be in that published paper?
Well, they get access to the Gerber files for all the test coupons. They get all the data and the raw data that has been put together. Also, we do a statistical analysis of all the data, and they get access to that. And it's a real time process. So every 2 weeks, we're going through and we're reviewing data. We're having industry experts from other companies comment on the data. So they get firsthand in and outs. Just looking at the paper, if you don't live it, you don't really gain a lot of you gain a lot more by participating. So the more you participate, the more value it is to your company.
Some of the other studies that I looked at are ranging from bare board processing, like the interlayer copper balancing project that's led by Intel, to soldering and reliability predictors, which are led by Nokia and Fujitsu, respectively. I know we don't have time to talk about each one, but can you give us a glimpse into the work that you feel is most groundbreaking?
Well, from the interlayer copper balancing project, one of the issues that we see with thick boards that have a lot of BGAs on them, primarily processor boards, say if you like 18 and 20 layer boards, uh, you have differences in the overall thickness of the board. And this project put together some design features, and we evaluated those features on trying to level the board, if you will. There's a significant amount of dips and dunks on a printed circuit board if you take a look at some of the high copper areas and some of the areas that are void of copper. So, and that impacts the assembly, and also it impacts the dielectric thicknesses, which in high speed boards are very critical. So, the goal of that project was to look at some design features that maintain the dielectric thickness and also the topography of the board. So that's sort of a key. One of the key items that comes out of that project are some know-how that board fabricator or designer can use to minimize that dielectric spacing variation that you would see if you just normally went through and laid out a board with standard features.
The material decision that which laminate you're going to use really plays heavily in every designer's mind. Would you say that over the years, HDP has probably reviewed every major subset of laminates as they come available?
We've looked at over 70 different laminate materials, and so that's a list. And we've come up with a standard coupon that we've used, and we've modified some over the few years to try and incorporate some things that folks were becoming. As we've gone into higher speed designs, there were some high speed coupons that have been added to it. There's also some other coupons that look at some different design parameters and the impact of those on reliability. So we have an MRT test board. I think it's an MRT 6 right now, version 6. And they're looking at an MRT version 7 for some other features. But we've used a lot of IST testing to do a lot of our evaluations, and we're looking at that, and we have a standard baseline comparison of some standard coupons that we look at for each material. Some of the materials, we try and get materials that are just almost ready for release The laminators use these test results to fine tune their formulas, and it's been a good project for the printed circuit board industry as a whole. I think because we've come up with a standard way of evaluating some of the materials.
Do new members gain access to the previously completed research?
Yeah, so that's one of the benefits of becoming a member is that you get access to all the past projects and all the past project data. Each project we write a final report on, and we characterize all the results of the project, and that is put together in a pretty concise report. Sometimes we have all the data, Gerber plots of the test coupons, the raw data, all of that material is put into an archived project folder that members can access.
So, for those who really want to kind of cut to the chase and haven't been members in the past, they could join and really kind of get a capture lightning in a bottle, so to speak.
That's right. You get a quick dive of 70 different materials in that particular project, and there's other projects that have similar results that would be very valuable to a member company.
Could we talk a little bit more about how the project design works? So, for example, if a company learns of a project that has already begun and decides they want to be part of it, can they join after the fact?
Yes, they can. Yeah, they can join. In fact, we've got a couple of new companies, Cotec and Umira, that have just joined, and they've jumped into a couple of projects on one on copper foil and another one on material copper coatings for high speed circuitry, looking at some different types of finishing. So that basically, once you become a member, you can request to be added to a mailing list, and you get all the project meeting information that is going on. And we try and keep our website. Each project has a web project list, and the past meeting minutes are in there, along with some of the presentations that have been made in the past. So it's pretty easy for someone to catch up to where things are at with a particular project.
Does work ever begin with the hope that over time it will, once completed, influence the industry standards?
Yeah, we have a project like that is in the idea phase right now that we're just starting. It's taking a look at next generation SIR testing. If you take a look at SIR testing, it uses a comb pattern, B23, IPC B23 pattern, which looks at a comb pattern and they test at 5 volts. Well, a lot of different product segments are seeing that 5 volts isn't really match what their products need. So if you look at automotive, they're looking at 1,000 volts. So that little comb pattern that was good for 5 volts isn't good for 1,000 volts, and you might not see the same type of issues. So the power flux and also the geometry of the comb pattern has changed. So we just have a kickoff meeting next week on this particular project. It's being led by Gen 3, Graham Nesbitt of that company. And he's very expert in reliability testing and has been chair of the IPC test group. So the intent of this project is to generate some data to validate some new test procedures of SIR to look at both the high voltage and the low voltage, which is in space, and some of the medical requirements are down to 2 volts and 50 micron spaces. So it's going to be taking a look at a variety of those and having people participate by doing testing and validating test methods for different types of voltage and geometry parameters. So I think that'll be a very good project, and the intent is to use that data to validate B53 coupon, which is a new coupon that they're considering at IPC. So that's one that kind of impacts that area.
With all the emphasis on electric vehicles, it seems that HDP could probably have 10 years of work just redoing all the work you've done for high power products.
Yeah, that is an area that we've looked at trying to get in. A lot of the automotive companies are very proprietary with with their designs and their technology, and trying to get more collaboration in that product sector is a very difficult job. We're still working. We think this SIR project will be something that will maybe drive more participation by automotive suppliers into that space. They need to realize that more and more of their products becoming more like computers that everyone uses today. So having good reliability data is very essential, and this is a good way. Participating in a consortium like HDP is a very good way to achieve that data.
Is there any other project or area that you'd like to discuss before we wrap up?
We've got a lot of projects in the high speed area. We've got one in ultra low decay glass, taking a look at some of the new glass styles. I think Madan Jagernauth, who's on this call, is a project facilitator for that. Maybe Madan, you could just kind of give him a little bit of background. Ultra low decay glass project.
Sure, Larry. So basically, the ultra low decay glass project is looking at skew in signals. As you look at high speed circuits, you're really looking at what's the spread of the signal over any length of a copper circuit. And the skew is really the spread of the signal. If you have too high a skew, then you get higher bit error rates in your circuits. So this is one of the areas where having the low dielectric materials helps to get higher speed circuits. As we look at things like wireless circuits and the frequencies that are necessary there and the data rates that we're getting on board level, we're now talking about 100 gigabit and above types of circuits. And for that, you have to have very well controlled products so that you actually can get the signal to noise ratio that you need.
Well, I know that folks who want to learn more about HDP and its goals can check out our podcast with John Davignon from June 2020, or they could visit pcdnf.com for our interview. And of course, you could always visit the hdpusergroup.org website for more information. Madan, Larry, it's always good to talk to you.
Thank you.
Thanks, Mike.
This brings us to a close to today's podcast. And thank you both for filling us in on the latest HDP research. Thanks also to our sponsor, Printed Circuit University. Get flexible, affordable electronics education on demand. Visit Printed Circuit University to see more than 100 hours of online classes from some of the top professionals in the field. This is Mike Buetow for PCB Chat. Have a good day.